We use the elimination method to solve systems of linear equations when both equations are written in standard form, meaning we have the x and the y variables on the same side of the equation. Our goal is to eliminate either the x's or the y's by adding or subtracting the two equations together. Now, the easiest way to do this is to make either the x's opposites of each other or the y's opposites of each other, or have the x's or y's being the same number and then simply subtracting or adding them together. Since these are not the same or opposites of each other, what we need to do first is multiply both equations by a number so that either the x's or y's are opposites of each other. I'm going to choose to cancel out the x's, so I'm going to multiply the top equation by 3, and I'm going to multiply the bottom equation by -2. The reason I chose those numbers is that if I multiply 3 times 2x, I'm going to get 6x. When I multiply -2 times 3x, I'm going to get -6x. Those are opposites of each other, and that is my goal, is to cancel out either the x's or the y's. So in this case, I'm going to cancel out these x's. So when we multiply, we just distribute the 3 to each term, and then the -2 to each term, and write two new equations. So to start, we have 3 times 2x, which is 6x, plus 3 times 5y, which is 15y, and 3 times 1, which is 3. Then we have -2 times 3x, which is -6x, plus -2 times -3 is -6y, and -2 times 4 is -8. Now, when we add these together, the 6x and -6x cancel each other out. We have 15y plus -6y, that is 9y. And then we have 3 plus -8, which is -5. Then we divide by 9, and we get y equals -5 over 9. That's the y part of our answer. We need to find a coordinate x, y. So our y is -5/9. Now from there, we take that and plug it in to either this top equation or the second equation, and we substitute in the -5/9 and for y, and then solve for x. To solve systems of linear inequalities, we need to graph each inequality separately. The first one that I'm going to graph will be the top one here. Its y is greater than 2x plus 1. And so since it's already in slope-intercept form, I know that my y-intercept is 1 and my slope is 2. So if I put a point at 1 and my slope is up 2 over 1, be about right there. Now I need to draw my line. Now how this differs a little from graphing linear equations, since this is an inequality, I have a greater than sign. Now since it doesn't have the or equal to, like this one down here, that means I'm going to be drawing a broken line, or a dashed line. It's going to look something like that. The next step is to look at this sign, and I see that it says y is greater than 2x plus 1. So if I come over to the y-intercept and I look greater, which is above the line, that's where all the solutions are. So I need to shade in everything above this line. So I will shade all of this area above the line. Now the next part is to graph the second inequality. This one has a y-intercept of 4 and a slope of 1/2. So to graph this one, I come to my y-intercept of 4, which is about here. Actually, I guess it's going to be a little bit higher, maybe about here. And I go down 1 over 2, should be about there. And now this time, since this is less than or equal to, I know that my line is going to be solid. So I'm going to draw a solid line right through like that. Now my inequality says y is less than, whoops, sorry about that, y is less than or equal to 1/2 x plus 4. So that means at my y-intercept point, I'm graphing or shading beneath the line. So this line, all of the solutions are on the line since it's solid, and everything less than the line. So I'm going to be shading down. So what we end up having is two lines with shading, and now the overlapping part, that's the part that is going to be the actual answer. So the part that overlaps, which is all of this here. So what this means is that any point in that part of the coordinate plane will be a solution if we plug in the x and y value into both inequalities. It would be true for both.